Hello students, welcome to Narayan PU College online classes. So in the last video we have discussed competitive questions of haloalkanes and haloarenes up to 40th. So I already mentioned whenever alcohol is treated with the SOCl2, then it follows the SN1 mechanism, and SOCl2 pyridine if it is there, actually SNI we will call, and it follows SN2 mechanism only, and you have to add the chlorine opposite to the OH that we have already discussed. And next question, see the question number 41. Clear ma? What the question they have given here is, and they have given this is the compound, clear, and then hydrolysis, H3O plus, and excess amount we have taken, they have taken here excess amount, then you will get the X, clear. So what X is, that is the question, clear ma? So H3O plus means, and it is acidic medium, so we are adding into the water H plus, then automatically water will be in the form of H3O plus ion, clear ma? So what does it mean here? It is a acid is added into the water, that is the meaning of that one, clear. And that now here we have the symmetrical compound it is, if you break this one you will get the same compound, so either this oxygen or this oxygen, that it is protonated, clear ma? So oxygen lone pair and here H plus, it donates pair of electrons to H plus and oxygen is get protonated, clear. Whenever oxygen is get protonated, then what the compound you will get, you see, I will write here, and in this one first of all, and oxygen, and here there will be a oxygen, and here H plus, and oxygen gets the positive charge, clear matters. Now this is oxygen gets the positive charge here. Now that oxygen is having the positive charge and it is unstable, then what it will do, it will gain the electrons from either this bond or this bond. There are two possibilities are there, clear. And one is, this is suppose bond breaks here, this is A bond, and just assume this is a B bond, clear. And if A bond breaks, I will write here, if A bond breaks, then what the compound you will get, you see, you will get the compound is, here there will be a oxygen, and here there will be a, this bond breaks, you will get, this bond breaking, so that's why, and you will get the positive charge here and OH here. Got my point? So this is carbon, this carbon is losing electron, oxygen is gaining electron, so oxygen gets the negative charge, already positive charge neutralized, and this is the product you will get when if bond A breaks. And if this bond breaks, then what the compound you will get, you see, you will get the compound is and O, and this is the OH, clear? And here OH, this carbon OH, and here you will get the positive charge. Now the question is, which bond breaks? Both bonds are breaking, but which bond will break faster? That is you have to identify, clear ma? That the bond breaking, it depends upon the stability of carbocation. Carbocation is forming here, which carbocation is most stable, and that bond will be broken. Got my point here? Yes. See now this carbocation is a simply it is a CH2, and that it is a primary carbocation. It is a which carbocation? Primary carbocation. Come to here, it is a secondary, and also here which one is there? Oxygen is there, clear ma? And oxygen and positive charge separated by which bond here? Single bond. Single bond means these are both positive charge and lone pair are in conjugation. When they are in conjugation, they involved in the resonance. Due to the plus M effect, this carbocation becomes most stable. It is primary and it is secondary and also stabilized by the lone pair of electrons of the oxygen. So it is more stable. It is more stable compared to this. This is which one? Less stable. So it is a less stable means which bond will break here? B bond break, not the A bond. That is clear ma? Now this is the, you will get the product. Now carbocation is formed, clear ma? And after then what they have given here? water they have given, water will be added here. Clear ma? I will write here. So H2O. H2O means, again you already know that oxygen is having lone pair of electrons and it attack on this one. Then what the compound you will get, you see, you will get the compound is, here there is a oxygen and here I will write, there will be a OH and here oxygen, hydrogen and hydrogen. Oxygen getting which charge? Positive charge. Why oxygen gets positive charge? Because oxygen is losing electrons, carbon is gaining electrons, so that's why oxygen gets the positive charge. You know, whenever oxygen gets positive charge, you know it is unstable, it take the electron from hydrogen. Then what the compound you will get, you see, you will get the compound is here oxygen and you will get the compound here, it is OH and here what is there, O and H. Clear? Now it is a like ether. Ether means it cleavage easily takes place. Now you know what happened here, and this bond electrons, you know, water we have added here, which amount? Excess amount water we have added here. Excess amount water we have added means, and this it will take the H plus ions here, it to convert into H3O plus. Then this H plus is removed, this bond electrons are free and these bond electrons will come here. When this bond electron comes, this carbon getting how many bonds here? 5 bonds. Already 4 bonds are there, 5 bonds. So that's why what will happen? This bond electrons will move towards the oxygen. Clear ma? Then what the compound you will get, you see, you will get the compound here is, you know, I will write here up. So what the compound you will get? You will get the compound here is, and OH and here there will be a C double bond O and here there will be a OH. Means here O minus you will get and H plus it will take, then it will be converted into H plus. Clear? It because we added H plus here, O minus and H plus, and you know you will get the OH. So this is the product you will get. Clear? So what is the option now? Option 2 is the correct one. Clear ma? Here aldehyde, this is, you know, double bond O is there, means here which one is there? Carbon is having how many bonds? 1 and here 2 and 3, means fourth bond is which one? Hydrogen. So this is your compound. Clear? So simple, you see, again once again it is somewhat difficult. So they have given here cyclic ethers, clear, and H plus they have given and H2O. So what they are asking, X should be the major product. Now first of all oxygens are there and H plus ion is there, protonation takes place. Whenever protonation takes place, after protonation and this bond, you know, oxygen having positive charge, unstable, either A bond breaks or B bond breaks. Which bond breaks? That depends upon the stability of the intermediate, and you are getting here one intermediate and another you are getting here another intermediate. This is less stable, it is only primary, but it is secondary and it is also stabilized by the plus M effect. So that's it is more stable, so that's why it won't be formed. Next here positive charge is there, they have given already water. Water means act as a nucleophile, and so that's why, and it donates the pair of electrons to make a bond and it will be converted into, you know, positive charge. One of the bond pair it will take from the hydrogen, hydrogen will be removed as a H plus here, then you will get, but here you know that this ether is there and cyclic ether, this ring will open and by taking the water take the H plus ions and you will get the, this bond electrons will come here and it convert into double bond and this bond will break. O minus will get, already H plus is there, we have used here excess and it will take, you will get the compound. So next one, coming to this is question number 41. Clear ma? Next one, coming to the question number 42. Clear? What the question they have given, you see. The question is CH3 CHOTS and here another one CH2 CH2 and CHOTS. Again they have given 2 times OTS and here CH3 and they mentioned here SH minus. Clear ma? It is one equivalent. They have given only 1 mole or 1 equivalent they have given here. They have given 1 equivalent and after then treated with the KOH. After then treated with the which one ma? KOH. You will get the product X. What is the product X here? Clear? You know that OTS is a very good leaving group. Clear ma? So OTS is a very good leaving group. So that's why toluene sulfonic acid, this is toluene sulfonic acid. So that's why, and that is very good leaving group here. Simple. OTS means TS means here, you know, OTS, and here O, and here double bond O, and you know, and this is CH3, toluene sulfonate. Clear? So here in this one, it is negative will come. If it bond breaks, what it will come? Oxygen negative, and it will be stabilized by resonance. So that's why it wants to always convert it into O minus by gaining the electrons, become a good leaving group. That is the concept here. So OTS is a very, very good leaving group. And what they have given here, one nucleophile they have given. What is the nucleophile they have given here? SH minus. Clear ma? So it is a symmetrical molecule. So one of this OH will be attacked here, and this will be removed as a leaving group. It will be removed. Clear ma? Then what the compound you will get? You see CH3 and CH, OTS, and here CH2, and you know CH, SH, and what you will get ma? CH3. Got my point ma here? Clear? Next one what they have given here is KOH. What they have given ma here? KOH. Clear? KOH means it acts as a base. KOH means what it is ma? It acts as a base. And see now, and before this you already know that in this molecule very good leaving group is there, and also internal nucleophile is there. What is there ma here? Internal nucleophile. And I already said NGP, neighboring group participation. Have we discussed or not? In the last video we have discussed what is the neighboring group participation. Internal nucleophile should be present in the molecule, at the same time good leaving group also should be present. So that's why you know internal nucleophile reaction takes place. Means what happened here? This will attack here, and so OTS will be removed. Okay? Then what the product you will get? I will write here, it is a 5-member ring. You see 1, 2, 3, 4, 5. You will get 5-member ring here. See now, there is a sulfur, and here CH2, you know, CH2, and the next one what it is there? CH2, 5-member ring I will write here. Clear? This is 5-member ring. Clear ma? So now I will take 1, 2, 3, 4 and 5. Clear? You know that second carbon 1, 2, suppose this I will put, you know, this is a H. Our sulfur is giving electron. Giving electrons means losing electron. Losing electron means which charge? Positive charge. Clear? Now you see on the second carbon, suppose just it is 1, and here what is there ma here? CH3, and after then CH2, and after then CH2, and CH, this is the 5th one, and to this CH what is there here? There will be a CH3. That is the compound. Got my point ma here? Now what they have given here? Base they have given. What is the base ma here? KOH, K plus and OH minus. Clear? On the sulfur, you know, when it is a highly electronegative atom having the positive charge, it is unstable. So that's why. And what it will do? This take the bond pair of electrons towards it. H plus will be removed, and that H plus will be taken by OH minus and removed as a water. Then what the compound you will get ma here? You will get sulfur here, and there will be a 5-member ring, and you know on this there will be a CH3 and there will be a CH3. So this is your product. Clear ma? So they have given 1 mole only. They have not given 2 moles. If 2 moles are there, 2 OTS will be substituted by the SS. So first we have taken once OTS will be removed, and this SH will be there, and very good leaving group is there. So that's why, and you know neighboring group participation takes place. What you will get here? NGP, neighboring group participation, internal nucleophile and internal leaving group. So that's why you know that you will get this product. And sulfur is giving electron, so that's why it gets the positive charge. So positive charge base they have given. Base accept the proton, so that's why bond electrons free. These bond electrons will come towards the sulfur. Sulfur is already having positive charge. Now gaining electron means negative, positive, negative on the same atom. Charge will be neutralized, and that is the compound. Next one. Coming to the question number 43. See the question number 43 what they have given. So here there is a cyclic compound. Tertiary butyl group is there here on the position, and there is a OTS. I already mentioned what is the OTS. Clear ma? Very very good leaving group, toluene sulfonate. Clear? So this is, and treated with here, you know, sodium acetate. What is the sodium acetate formula? CH3, C double bond O and O minus and Na plus. ONA actually, and O minus and Na plus. Clear ma? So that is, what is the major product A is? Clear? What the product you will get it here. Clear ma? So they have given here heating also. Clear? And you know that in this case we will expect here, you know, negative charge is there. Negative charge and heating we will expect here, you know, elimination reaction. But you know that what they have given, it is a weak base. Clear ma? It is not a methoxide ion. Methoxide ion is very strong base, but here it is a which base? Weak base. Why it is a weak base? You know that CH3, C double bond O minus is there, and this negative charge and double bond are, you know, in the separated by single bond. They are in conjugation. When they are in conjugation, they involved in the, what it is here, resonance. Clear? So that's why negative charge on the oxygen atom is not free to accept the base. To accept the which one here? Sorry, to accept the proton. If it act as a base, and what it will do, it accept the proton. To accept the proton, it should have the more negative charge, but this negative charge is involved in the resonance. So that's why it won't be act as a strong base here. Instead of base is, now it act as a nucleophile. Now it act as a which one here? Nucleophile. So you know that here CH3, C double bond O, and here O minus, and there will be a Na plus. Clear ma? So what happened here? This what happened? Nucleophilic substitution reaction takes place. So nucleophilic substitution reaction means, you know that, and it is a like SN2 reaction. It is a, what it is here ma? SN2. So what happened here? And you know, it is a very good leaving group is present here. So that's why whenever, and it is, you see, equatorial position, and it will attack from the axial position, opposite position, and this leaving group will be leave, and it will be removed. Clear ma? So that's why what happened here, you will get the compound is, this is the compound. Clear ma? So you will get the compound, and here OAC we will say simply, and here there will be a tertiary butyl. So this is the which product ma here? Major product. This is question number, what it is ma here? 43. So option 2 is the correct one. Clear? Next one, coming to the 44. Clear ma? So coming to the 44, energy profile diagram here. We have already discussed when SN1 and SN2 reaction is there, and we have discussed, you know, what it is here, energy profile diagram. But here they have given for elimination reaction. You know that the first of all they have given CH3 and CHOH, and here you will get the CH3, and here there is a H plus ion, and compound CH3 and CH3, and you will get H and H, there will be a positive charge, and after then, and you know, intermediate will be formed, CH3 C plus, and again there will be a CH3, and then H minus minus H plus, elimination reaction, you will get here CH3 CH and double bond CH2. Yeah, they have given, this is the reaction. For this one they have given energy profile diagrams, you see, and first energy profile diagram is energy here and reaction coordinates RC. So what is the first one? This is the graph. This is the graph. Clear ma? Coming to the second one, second option here. What is the second graph here? See, same E and reaction coordinates, and the second graph here is same like first one only, but here this is clear. Next one, coming to the third one. Third one graph they have given E and reaction coordinates. This is one. This is the one. Next one is fourth one. Fourth one same, and here E and R reaction coordinates, This is 4. Clear ma? And I already mentioned in the previous, you see, how many steps are there and those many peaks will come in the energy profile diagram. Clear ma? Now you see, OH2 here, there will be a one transition state. This is transition state 1. And for conversion of OH, this is to this, there will be another transition state, that is transition state 2. And from here to here, there will be a transition state 3. Clear ma? So how many peaks you should have? There will be a 3 peaks. 1, 2, 3. It can be answer 1, 2, 3. It is also can be answer. And here 1, 2. It won't be the answer. So answer is there among these 3 only. Clear? But you know that these 2 are not the correct answer, because you know that this is the reactant and this is the product. Clear ma? You know this is reactant, and if you take the transition state, always transition state having the higher energy than the reactant. But here you see this is the reactant. First of all, energy is decreasing. Clear ma? Energy decrease, then again energy is increasing. It won't happen. Got my point here? And here also you see reactant energy is decreasing and again increasing. So first of all, you know, when transition state forms, and that transition state, you know, having the higher energy than the reactant. Clear ma? So that's why these 2. And see here, it is the reactant. First of all, what happened? This transition state directly energy is increasing, but here energy is what it is? Decreasing. So that's why always reactant and transition state is there. It should not come curve like this. If they give like this, it is correct. But first they have given, and decreasing means energy decreasing. So these 2 are not the options. You see here, one transition state, one peak, another peak, and another peak. So that's why this is the option. Clear ma? So that is question number, what it is here, 44. And last question is there here, question number 45. And coming to the question number 45, see now, and here this is also important question. So there will be a double bond, and here double bond O, and here O, there will be a CH3 and OH. Clear ma? So they have given here H2SO4 and heating. H2SO4 and heating, you will get X. And they are asking what will be the X here. They are asking what it is ma? What will be the X. Clear ma it is? Now you see. So if you see this, you already know that here H plus they have given. What it is ma? H plus they have given. H plus they have given means, you know, there are 2 oxygens. Here there is a 1 oxygen, and here there is another oxygen. Clear? And which oxygen, you know, it gives H plus. Which oxygen will get protonated? That you have to first identify. Suppose just assume this oxygen is protonated, then what the compound you will get, you see? You will get the compound is double bond O, and here there will be a CH3, and here and OH and H, and oxygen will get which charge? No, positive charge. Now after then oxygen is positive charge means unstable, so that's why, and this bond will break and this carbon gets the which charge? Positive charge. If this carbon gets the positive charge, there will be a double bond, and here and this carbon gets the positive charge and water molecule will be removed. And now you know that here this positive charge will not be stabilized by this double bond, because you know that positive charge and a double bond is separated by which bond? Single bond, but it won't involve in the resonance. Why? Because here which group is there? Electron withdrawing group is there. It withdraws this bond electrons towards the oxygen. It won't allow oxygen to move these pi electrons to stabilize the positive charge. Got my point here? So that's why, and this positive charge will not be stabilized by resonance so easily. Clear? So that's why protonation takes place on this carbon, not this carbon. So you know this is a wrong if you protonate that one. Clear? Then what you have to do? You have to protonate second oxygen. What is that oxygen here? There will be a double bond, and here, and you know there will be a OH. Clear? So what will happen here? Protonation. Protonation means what will happen here? There will be a O plus. There will be a which one? O plus. Clear? So then what happened here? Clear? So if you take options, if you see what they have given in this condition, Clear ma? So 45, if you see the answer for the 45, you know now what happened, you see in this case, and H plus is formed here. Whenever H plus is coming here, then this bond electron, you know, oxygen is getting positive charge, means it is unstable. Unstable means what will happen? This pi bond and this pi bond is in conjugation. These electrons will shift here, and then this electron will move towards the oxygen, because these electrons will shift towards the oxygen, because oxygen is more electronegative. Then what the compound you will get, you see, you will get the compound is, clear ma? So this is, you will get OH, oxygen is negative charge, already positive, and now, and this double bond is shifted here, and this carbon is losing electron, there will be a positive charge, and here OH. Clear ma? Now you know that it is a which carbocation? Secondary carbocation. And you already know that when carbocation is intermediate, if there is a chance, then they involved in the resonance. See now what happened here in this case. Clear ma? And this is a positive charge. Now this methyl group, this is a which group ma? Here it is there, CH3, and this methyl group along with its bond electron will shift to this carbon. Then what happened, you see, and you will get, this is double bond and there will be a CH3, and now you will get the compound is here, there is a OH and double bond, and here there will be a positive charge, and you know, and here what it is ma? OH. Clear ma? It is a which carbocation? It is, you know, tertiary carbocation this is, and this tertiary carbocation and also stabilized by the plus M effect. So it will be a most stable compared to this, so that's why it will be formed. Clear my it? Now you know that it is a tertiary carbocation. Now in this one, what will be there here? There will be a CH3. It is a what it is ma? CH3 is there here. CH3 minus and plus, you will get CH3. Now positive charge is there. Now heating they have given already, means which reaction? Elimination reaction, double bond should be formed. You see now here positive charge is there, this positive charge should be neutralized. How it will be neutralized? And you know that, and here H will be there, because benzene ring is not formed. If benzene rings here, both bonds are in conjugation. If another bond forms here, then automatically benzene rings comes, and benzene ring is most stable. So that's why one of the hydrogen will shift here, this bond H plus will be removed, bond electron will shift here, double bond you will get, and you will get the compound here is, see my final compound, there will be a OH, and here double bond and CH3, and here there will be a OH, and here what is there, CH3. So this is your final product. See once again, and you know they have given H2SO4 and double here heating. So first of all, protonation should take place on which oxygen? This oxygen or this oxygen? That you have to identify, because this double bond and this double bond is in conjugation, so bond electrons will move towards the oxygen, because oxygen is more electronegative. So that's why if this oxygen is protonated, and that oxygen will be stabilized in this way, but it won't be formed. It is less stable compared to this. So that's why, and here, and resonance is there, pi bond, this pi bond is separated by single bond, and this bond electron comes here, this bond electrons moves towards oxygen, so oxygen become OH, and here you are getting positive charge, secondary carbocation, and the carbocation involves in the rearrangement to get the more stable carbocation here, and CH3 will come, CH3 minus, and here positive bond formation takes place. Here this is positive tertiary carbocation and also stabilized by the plus M effect, so most stable this is, so it will be formed. Then to get the stability, and one hydrogen will be removed to get the benzene ring, and you will get this. So option is here, option 4 is the correct one. So now see the AIPMT NEET questions are there here. First question, which one of the most reactive towards SN1 reaction? Means they have given here alkyl halides. First one is C6H5, CH, and another C6H5 and Br. This is the first option. Second option C6H5 and CH, and there is a CH3 and Br, and the third one is there C6H5 and here CH3 and C6H5, and here there will be a Br, And fourth option C6H5 CH2Br. These are the four options. Which one involves in the which alkyl halides involved SN1 reaction very fast? Clear ma? I already said the reactivity of the SN1 reaction depends upon the stability of carbocation. Which carbocation, which alkyl halide gives the stable carbocation, and that alkyl halides involved in the SN1 reaction very fast. And see, this is the first one what they have given here. And CH, if the bromine will be removed, positive charge will be formed here. This is carbocation. It is stabilized by the two benzene rings here, resonance. Clear ma? And this positive charge is stabilized by the two benzene rings here. And next one what is there? And here there will be a CH and positive charge, and here this is, and this positive charge carbocation is stabilized by here benzene ring resonance due to the resonance, and also here hyperconjugation, 3 hyperconjugations. But this is most stable than this, because carbocation is stabilized by 2 benzene rings, but here only 1 benzene ring, but here hyperconjugation. Clear? Next one, what is the next one they have given here is, and C and CH3 positive charge, and here there will be a 2 rings. Clear ma? Last one is there will be only 1 ring, that is CH2 plus. Clear ma? So what is the stability here? Which carbocation? Suppose if I write this is 1, this is 2 and 3, 4. Which carbocation is most stable? Clear ma? This is, you see here only positive charge is carbocation is stabilized by 2 benzene rings, but here also 2 benzene rings and also hyperconjugation. There is no hyperconjugation here, so it is most stable compared to remaining all. If you write the stability order here, third one is most stable, and after then you will get the second one, and after then first one you will get the first one, and after then second, and last is 4. Which one is most stable here? This carbocation. So that's why these alkyl halides involved in the SN1 reaction very fast. Clear ma? Next one, question number 2. Coming to the question number 2 here. What is the question number 2? So very important question, most of the time they are asking, and very easy also. And CH2Br is treated with, first one is magnesium and ether. Magnesium and ether. You know alkyl halides, magnesium and ether. What is this one? Preparation of Grignard reagent. And you know that C6H5 and CH2MgBr. This is the Grignard reagent. Clear ma? When alkyl halide treated with the magnesium and dry ether, and you will get the Grignard reagent. Clear? And Grignard reagent, and after then what they have given? H3O plus. H3O plus means what it is meaning? They have given, so H plus in water means H plus is adding. When H plus adds, where it will attack? Clear ma? You know that it is a magnesium and carbon bond is highly polar. So that's why magnesium, this bond breaks and these electrons will shift towards the carbon. Magnesium always gets which charge here? And partial positive charge, and bond breaks here. You will get the magnesium is a positive charge and carbon gets the which charge? The negative charge. Clear ma? And what we added here? H plus and you know here C minus. So you will get the CH3. So what the compound here is C6H5 and CH3. CH2 and H will be added. So you will get the CH3. This we will called as a toluene. Clear ma? So that is option 3 is the correct one. Next one, following compounds which will give the 4 option, which of the above compounds on being warmed with iodine solution and NaOH will give the iodoform reaction? Means there we have to identify here which of the following alcohol will give the iodoform test. I have already mentioned what is the iodoform test. Clear ma? It is to give any alcohol to iodoform test, that alcohol must have the group is CH3CHOH. Clear ma? See which alcohol has. First option CH3 CH2OH. This alcohol is have this group or not? CH3 CH2, what I can write? CH and OH. This can give iodoform reaction. Clear ma? Iodoform test. Next one is second one, CH3 C double bond O and CH3. This is ketones. For alcohol this group, for ketones this is the group should be required. Aldehydes are ketones, this group must be present. That we will discuss. Aldehydes, ketones and carboxylic acids. For alcohol, CH3CHOH group if there, and that compounds will give the iodoform test. But aldehydes and ketones, if they have CH3CO group, then they will give. Now you see here CH3CO group is there, so it will also give the iodoform test. And next one, and third one is CH3, you know, CH, and here CH3OH, and it is there CH3COOH group, so it will also give. And next one, fourth one what it is, ma? CH3OH. Will it give here iodoform test? No, because it should have CH and CH3. So first one, second one, and third one will give the iodoform test. Next one, question number 4. And coming to the question number 4, and see the question what they have given. CH3Br and here KCN. They have given here KCN. Clear, ma? Then you will get the compound is A. A is hydrolyzed. H3O plus means acid hydrolysis. Clear, ma? And we will add acid into the water. So that is acid hydrolysis. You will get the B. And B is treated with lithium aluminum hydride. You know, very good reducing agent, powerful good reducing agent. So what is the product you are getting? Clear, ma? So you know that when alkyl halide is treated with the KCN, then you will get the product is KBr will be removed. And what is the reaction, ma? You have already know. With the AgCN you will get the, you know, with the AgCN you will get the isocyanide, but with the KCN you will get the cyanide only. This is clear, ma? That is the compound A. And compound A on hydrolysis. Clear? You know that already I have mentioned in the haloalkanes and haloarenes. When cyanides undergo hydrolysis, you will get the acids. Clear, ma? NH3 will be removed. N will be removed as NH3. You will get the acid. CH3COOH. Important, you have to remember this. Clear? So when cyanides undergoes acidic hydrolysis, will gives the acids. So acid is there, and lithium aluminum hydride. You know that lithium aluminum hydride is a powerful reducing agent, and powerful reducing agent means, you know, AAA process we have A and A and A. You know that aldehyde, alcohol oxidation aldehyde, aldehyde oxidation acid. And if I take strong oxidizing agent, directly alcohols are converted into acids. But here acid is there, strong reducing agent is there. Acids are reduced to aldehydes, aldehydes are reduced to alcohol. If you use strong reducing agent, directly acids are reduced to alcohol, that is only. And strong reducing agent and followed by hydrolysis, you will get the compound is alcohol, 2 carbon alcohol, that is ethanol. This is the answer. So your option is ethyl alcohol. Option 2 is the correct one. And coming to the question number 5. So what is the question number 5 here? The products are formed when the following compounds are treated with, following compound is treated with, and bromine in presence of FeBr3. This is the question. So they have given here the compound. What is the compound here? CH3, and here also there will be a CH3. Clear, my dears? Now, and treated this one with the bromine, in presence of FeBr3. You know, bromination reaction. Clear, my dears? So what is the, you will get, what is the major product here? Clear? You know that CH3 groups are there. You know CH3 groups are present at meta position to each other. Then you know that bromination takes place. The electron donating groups, these two electron donating groups means, you know that, and bromine will be added at the ortho position or at para position. Clear, ma? So now, and we have 2 ortho position. This is ortho position, this is ortho position, this is para position, where the bromine will be added. Suppose just assume at this ortho position, suppose it is added. Then what happened, you see, ma? You know that CH3, and here there will be a bromine, and here there is a CH3, and here that is first bromine, but it won't form. Why? Because you know here there is a 2 CH3 bulkier groups are there, and bromine is very big bulk group. So that's why due to this bulkiness there will be a repulsion. So that's why it is a unstable. So this ortho position bromine will not be substituted. So where it will be? Here. So that's why you will get the compound here is, clear ma, CH3, and here there is a CH3, and this ortho position bromine will be added, and plus another one, it is where it, which position? Para position. Para position means, you know, this is CH3 and here there is a CH3 and double bond, already there will be a bromine here at ortho position. Now this is a para position. So this is your answer. Answer, you know, option 2, 3 is the correct one. Next question. Question number 6. Clear ma? Question number 6. And in SN1 reaction on a chiral center, there is a SN1 reaction. Clear ma? It is a SN1 reaction. So what is there mentioned here? 100% retention, 100% inversion, 100% racemization, inversion more than retention leading to the partial racemization. Clear ma here? Now, and we have already discussed SN1 reaction means racemic mixture you will get. Racemic mixture means what it ma? You know, 50% of retention and 50% of inversion product you will get, and that we will call as a racemic mixture. But what happened here in the SN1 reaction? You know, suppose any, I will take simple SN1 reaction, CH3, or simply you take, suppose CH3, CH3, CH3 I have taken. Clear ma? So now bromine will be there. So what happened here at first step, and you know, bromine will be removed. Bromine will be removed means there will be some transition state. What is that transition state ma here? CH3, and here there will be a bromine. Bromine gets the negative charge and this is positive charge. Clear ma? So next what happened, you know, next one is you will get the carbocation is a intermediate. CH3, and here there will be a CH3 and positive charge, and there will be a what? It is a negative charge. Clear? Now this is carbocation. Carbocation is, you know, this is carbocation CH3, and you know CH3, and here there is a CH3 and a positive charge. Clear? And now OH minus nucleophile may attack from the front side or may attack from the back side. Clear? But you know what happened actually is, we will get 50% retention and 50% inversion we will say, but it is not exactly correct. Why? Because I have mentioned here tertiary, they have not mentioned here tertiary. I have taken tertiary alcohol, it can be secondary also. What happened in this transition state, and we have already added which one here? Nucleophile. Clear? This nucleophile, some amount of this nucleophile attack on this carbon. Why it will not attack from the front side? Because front side is bromine is leaving. Bromine is negative charge, OH also negative charge, there will be a repulsions. So that's why some amount of this nucleophile attack from the back side at the transition state only. Clear ma? Attacks from the back side means which you will get? Inversion product. Clear? And remaining after carbocation form, and then some remaining nucleophile will attack from the front side and back side. Which one will be more here? Already OH minus attack from the back side here, some amount formed. Here also OH minus attacking from the back side. Some more amount of the inversion product will be formed compared to the, what it is here? Retention product. So that's why inversion is dominates. It is not exactly 50%. Just assume it is suppose 55%, then retention product will be a 45% like that. Clear? So that's why always in the SN1 reaction inversion dominates the retention. Clear ma? So that is question number 6. Next coming to the question number 7. So this is we have already discussed in the previous. Clear? So I am not going to discuss question number 7, and coming to the question number 8. The compound C7H8 undergo the following reaction. So what is the answer? They have given C7H8. What they have mentioned here? They have mentioned 3Cl2 and heat. You will get the compound A. Then after that compound A is treated with the bromine and iron. Then you will get the compound B. And compound B is treated with zinc and HCl. You will get the compound C. If you see the answers, and bromotoluene, metabromotoluene, beta-bromotoluene, and 3-bromo-2,4,6 trichlorotoluene means there is a benzene ring. That is, they have given from the options, we can easily understand benzene ring. So this will be a, you know, this is the compound CH3, toluene this is. Clear ma? 6 carbons and here 7 and 5 hydrogen plus 3 hydrogens. This is. Now you know that it is 3Cl2 and heat. Clear? If they give here Lewis acid, then chlorination will takes place on the benzene ring, but they have not given here any Lewis acid. Like you see iron they have given. If they give iron here, chlorines will be substituted on the benzene ring. So that's why. And chlorine and heat. So that's why which one takes place? Allylic substitution. Clear? Allylic substitution. How many chlorines they have given? 3 moles. Means 3 hydrogens will be replaced by the 3 chlorine atoms and minus 3 HCl will be removed. You see, ma? So what the compound you will get? You will get the compound here is CCCl3. So how many chlorine atoms are there? 6. 3 are substituted here. 3 hydrogens and the remaining 3 chlorine atoms will be removed as a 3 HCl. Now it is treated with the bromine and iron. Clear, ma? FeBr3 you will get it. FeBr3, you know, Lewis acid, that is. Now CCl3 is a powerful electron withdrawing group. Chlorine atoms are there to the carbon. Chlorine is more electronegative than the carbon, so chlorine will take the electron from the carbon, carbon will take the electron from the benzene ring. It is a electron withdrawing group. Whenever electron withdrawing group is there, and you know it is a meta directing group. Whenever it is meta directing group, bromine will be added at which position? Meta position. So that's why there will be a CCl3, bromine should be added at meta position. And after then what they have given, zinc and HCl. You know it is a reducing agent. I already mentioned metal and any acid is there that will act as a reducing agent. So that's why it provides the hydrogens and chlorines will be removed as a, you know, HCl. So hydrogens will be added. Again you will get here toluene. So there will be a CH3. It provides 6 hydrogens, and 6 hydrogen means 3 hydrogens will be added to the carbon. Remaining 3 hydrogens and 3 chlorines will be removed as a HCl, and here bromine. This bromine will not be removed. Why? It is directly attached to the benzene ring. Clear, ma? So you will get here meta-bromo-toluene. That is your option. So this is about the, you know, competitive of haloalkanes and haloarenes.